My name is Ryan Dobbs, and in this screencast I'll be showing you how to build a real-time grid component using Laravel, Vue.js, Vuex, and Socket.io. This is the type of functionality we're shooting for. As you can see, clicking in one browser, the update occurs in both. So who am I? I'm a developer based in Albuquerque, New Mexico, like James Brown, whose format I'm borrowing for the beginning of this presentation and to whom I'll give credit shortly. I've also come to Vue.js through Laravel. On Twitter, I'm at DobbsRyan. On GitHub, DobbsRyan, and my website, ryandobbs.com. A quick thanks to Taylor Otwell, the creator of Laravel, Jeffrey Way, creator of Laracasts, and Evan Yu, the creator of Vue.js. The tools these guys are creating, the documentation and the teaching, it's allowing developers to do some very cool things. And a quick thanks to James Brown for posting his screencast. It does a very nice overview of Flux and Redux and gets into the specifics of Vuex, how it capitalizes on Vue.js's reactivity system, and he also applies Vuex to a counter component for his example. And finally, a quick thanks to Niall O'Brien, who demonstrates Vuex as well using a message component. If you're familiar with Laravel, then you're most likely familiar with some of these tools. Also, we'll be using Laravel for the project codebase and Homestead as the development environment. Current versions at the time of this recording, Laravel 5.2, Vue.js 1.0.25, and Vuex, it's not at 1.0 yet and may be changing, but it's currently at 0.6.3. And quickly what we'll be covering, we'll do a Laravel install using the Homestead environment. We'll be adding a few npm packages. Then we'll be covering the main files from the Laravel perspective that will be processing the data posted when the user clicks on a cell. We'll also be creating the socket.js file that will be handling the node server. And then we'll get into the implementation of Vue.js, Vuex, and Vue resource, which will require the compilation of a number of files or modules. And then there are a couple of odds and ends that we'll go over. And then we'll test out our component and see it in action. A couple of related resources. I have the code that we're building here on GitHub. And as a GitHub gist, I've also done a little tutorial that goes through this whole process as well. So let's get started. I'm going to create a new Laravel install, and we'll call it Real-Time Grid Component Screencast. Next, let's edit our hosts file. So we'll copy this line and add screencast. Now my workflow has me log into the Homestead machine. Now we'll go to the new project directory. What we're doing here is setting the path to be served by Homestead. So present working directory, and we'll copy that. Now when we run serve, and we're calling this real-time grid component screencast.app, we will serve to this path and the public folder. And now let's check to make sure that worked. So we'll go from this original code base for my learning to the new one that we'll do together now. And it works. I'm going to close out of the Homestead machine. So I'll go back into the new project code base and run npm install. And what this is doing is installing all of the dependencies that come with Laravel by default. And now that that's done, we'll install Gulp. Laravel's Elixir plugin makes use of it. Gulp is what will allow us to compile down, in our case, the JavaScript files that we'll be creating having to do with Vue.js and Vuex. And now we'll install a few more packages that do not come with the Laravel install and which will be useful for our real-time functionality. So we'll be installing Socket.io, which opens the socket connection between the client and the server. IO Redis, which is just an additional Redis client for our node server. We'll be installing Vue and Vuex, as well as Vue resource, and finally Laravel's Elixir Vueify plugin that Jeffrey Way created, and we'll be saving these to our list of dependencies. This Laravel Elixir Vueify plugin is what compiles down our Vue and Vuex modules and allows us to use the ES6 syntax. Gulp on its own will just compile the JavaScript or CSS into one file for JavaScript, one file for CSS. And per the Laravel documentation, we will be installing pRedis because we want to broadcast using Redis to our socket client. Opening the project in Sublime, we'll begin from the perspective of Laravel. There are three main files that we'll be working with. One is the routes file that currently exists, and the other two have to do with a controller and an event. We'll get to those in a second. So when a user clicks on a cell in our grid, we will be posting the row and column index values to the Laravel backend, and it will be picked up by this post route. We will give it the route API update active cell, which is an arbitrary naming convention, and we'll be calling on the active cell controller and give it a method called method. It'll be the active cell controller that triggers an event that broadcasts the row and column values passed in from the user action that ultimately ends up making its way to our node server. To set up that controller, we'll run the following: PHP artisan make controller active cell controller. Now that that's done, we go look and we have our controller. So we'll create the method called method and include the request object that is a part of Laravel service container, allowing us access to the values posted. So we'll set a row index variable from the request row index value fed in, and we'll do the same for the column index value. We'll implement the global event helper Laravel uses to fire events, and we'll new up an instance of user changed active cell, the event we still need to create, pass in the row and column index values. Since we're already referencing the new event, let's go ahead and use the path to the new event. So to recap, our user changed active cell event has access to the row and column index values passed in through the request object when the user clicked on the cell and it was posted from the front end. Let's not forget the semicolon here. So PHP artisan make event user changed active cell. Now before we go to the event, let's update one thing in config broadcasting.php. So by default, Laravel uses pusher, and we're going to change the broadcast driver to be Redis. Now whenever an event broadcasts, it will be broadcasting using Redis, which is what we will be setting up our socket.js file to listen for. So our new event class is here. The first thing that we need to do is make sure that it implements the should broadcast interface. We'll add the row index and column index properties to the constructor. And finally, we will add the clicked cell channel. And again, this is just an arbitrary naming convention. Oh, and before I forget, protected properties are not serialized by Laravel for broadcasting, so we need to make them public. And that should be it. So to recap, our constructor takes in the row index and column index because those are the values that are being passed in when the user clicks on the cell and the event is triggered. Those values are then serialized and broadcast to the click channel. So now we're ready for our socket.js file and implementing socket.io. So I'm going to create the socket.js file, and it will be in the root directory here. So here we require the HTTP module and get the server. We'll be using socket.io, so we'll require that in and pass it our server. We'll be using the IO Redis client, and from one of the Laracast tutorials, Jeffrey Way had recommended that. Redis above was returning the equivalent of a class, so we'll instantiate it into an object here. And now we're subscribing to the channel that we set back in the event class. Whenever any kind of message comes through on that channel, here's what we're going to do. If we have any trouble, we can verify that the information is making it to this point. So we'll parse the message because it will have been packaged with both event and data properties. This is the format that we will send along to the client. So we emit the channel with a colon and then the event name, and then as the second argument we pass the data. And finally we set the server to listen, and we're going to say port 8080, and note that we will be referencing this port in our Vue module later on. Now we should, from our homestead machine, be able to start up the node server. And for that we'll run node socket.js, the name of the file we just created, and we get an error. This is probably happening because the code that I was using for my own learning, I had already used the port 8080, so let's change it to port 8081. And we'll restart node. This isn't the best way to test. We haven't passed any data in, so we're not getting anything from our console, but the fact that we don't have an error, the fact that it hasn't gone back into insert mode, we can assume that the server is up and running. This brings us to our Vue.js and Vuex setup. The first thing we'll want to do is update our welcome view. So we'll update the title to real-time grid component screencast. we'll add the app tags that will include the grid component. We'll also be referencing the js/main.js file, which will be the compiled version of our Vue and Vuex module files. And here's how the scaffold of those files will be. We'll begin with the main.js file in the resources assets JS directory. The two folders that we'll create will be a components folder and a Vuex folder. Within the components folder, we'll create the app.vue module. We'll also create the grid.vue module. Within the Vuex folder, we will create the action.js module. And then the store.js module. So as a recap, we have set our scaffold within the resources assets JS directory, and we have our main.js file, our components directory with the app.vue, grid.vue, our Vuex directory with action.js and store.js. These modular files will be compiled into this main.js file. The main.js file will eventually end up within the public directory, and when we run gulp, which will run the Laravel Elixir Vueify transformer, it will create a JS folder and place this main.js inside, which will be referenced by main.js here. Let's close out these files that we don't need. And now we'll begin to fill out the contents of these files. We will start with main.js. First, we'll import Vue from the Vue module that we imported through npm install. We import store from Vuex store. The store is Vuex's single source of truth, as the documentation states. Each browser will have its own identical representation of the store, and when the user clicks on a cell, the information that gets passed to the server will be sent back to the client through a mutation, and that mutation is what will update the store. And we'll directly reference the app module that we will fill out shortly, and within the app module we'll be able to reference the grid component itself. And within the app module, normally if this were a larger application, we would be able to include many different kinds of components. Here we new up our Vue instance and reference the store directly. We're using the ES6 object shorthand. We're binding the body element to our Vue instance, and we'll also include the app component. The only thing different about what we've done here versus any normal Vue instance you're creating is that we're adding the store. And by doing so, all of the child components of the app have access to the store. Our app.vue file is pretty straightforward. We start with a template tag. This is just Vue component convention. We're referencing the app component through the div with the ID of app, and this is bound to the body element we referenced in our main.js file. And then we reference our grid component. As I mentioned before, this is where we would also be able to add any additional components that a larger application may have. For script tags, we'll import the grid component from the grid module. and we'll immediately export it to make it available to the app module. So for building up the grid component itself, I'm going to go ahead and paste in the code from my previous version because I actually copied it straight from this example anyway. So this is the grid component example from Vue, and it's a table wrapped in template tags. A few things to keep in mind are columns, data, active row index, active column index. These are our data that are coming from the store, our initial state, as well as this make active cell method, which is bound to a click event. These expressions here, which are being evaluated and affecting a class that will be applied or not, the class being active row and active column, and using this vbind directive, the colon is the shorthand for that, as the v-on having the @ symbol as the shorthand. So a quick explanation. The columns value here is an array of data coming from the state, and that will have the information we need for the header row. The data is an array with little JSON objects inside that have the values for each row. So we're looping through, and each iteration is applying a row index and a column index value that we can retrieve, and when the user clicks on the cell, the make active cell method being triggered by that action will be able to retrieve the row and column index values and pass those along. That's what ultimately gets posted, sent to the server. The server responds. It's going to update these values, which are also in the state. When these values are updated, these expressions will continue to be evaluated. Everything's reactive. So these expressions will be evaluated, and the row index and the column index, Vue knows and associates with the DOM with these cells the index values related. So when these values are updated, when these expressions evaluate to true, active row and active column will both be applied as class styling. Hope that made sense. For the script section of our grid component, we'll import our Vue instance. We'll require in Vue resource and tell Vue to use it. This way we'll be able to post to our server. Next we'll import the socket.io client, and it will have the open connection with the socket on the server. We'll apply the homestead IP address as well as the updated port to the socket client and set the socket variable on it. We'll import the update active cell position action from our actions file or module, which we have yet to create, but that will be what will eventually allow us to dispatch mutations that are able to update the state. Vuex option block will contain our actions. So this is directly referencing the imported action. Our getters are important because they keep the data that was referenced above, the columns, data, active row index, active column index, which is our state, in sync with our components. So the getters are meant to take the state directly. The documentation also mentions that they perform in the same way as computed properties. So a change to the state will trigger the getters to update the DOM. Within this ready hook, we will reference our socket. Socket.io takes in the formatted string that we pass from the node server. So it's listening on that channel. And when it receives a message on that channel, it will call the update active cell position action and will pass through the row index and column index data that was passed through the socket connection as well. And this is out of place. And we'll have the one method that we referenced up in our template called makeCellActive. This is the method that gets called when a user clicks in a cell in our grid. We'll go ahead and console log the row and index value. We'll set up the post request using Vue resource. We'll pass it the row and column index values and send it to the route that we set up way back in the beginning here. And finally, we will add our styling. And in this case, once again, I'm just going to copy the style that came from the Vue example. I have removed some of the styling that's no longer being used and have added this background color for the active row and active column classes when they are applied. Next up is our action file. So this is where we create the update active cell position action. Actions, as Vuex indicates, expect the store, and the store is our first argument, but we are referencing the dispatch property through ES6 destructuring, and then the next arguments will pass in a row and column index values. So the action is what dispatches the mutation, and that's what we have here. Active cell position is the mutation, and we pass along the row index and column index values. And that brings us to the store where both our mutations and our state reside. We reference our Vue instance and import Vuex. Here we tell Vue to use Vuex, and that is what gives us access to the store. So we're newing up an instance of the Vuex store. So the store is comprised of both the state and mutations. And so that you don't have to watch me type, I'll go ahead and paste in the code for both sections. So the initial state is set with an active row index of -1, an active column index of -1. Our columns, these are the values for the header row of the table. The data makes up the body of the table. We return these values because we've set the state as a function. And our mutations, we have one mutation that we access from the update active cell position action. So when the action is called, the action dispatches the mutation receives the state and the row index and column index, and mutations are the only things that can make changes to the state. So here we're directly updating the state with those values. When those values are updated, they're changed here, and this brings us back to the grid component itself and the getters, the active row index and active column index, responding to that state change and affecting the DOM in the way that these two expressions are evaluated, updating the class, which gives us our active cell. As for a couple of odds and ends we need to take care of, let's update our gulp file to include the Laravel Elixir Vueify plugin. And we're going to change this line to the following. And this will then compile all of the modular files into the main.js file. And we'll do that now. And we have an error. cannot find module Vuex actions. That's because it's not named actions. So we pulled in the actions. Yes. Save that. Rerun gulp. So now we should have our public JS main.js file. Not much to look at, but it is all of the JavaScript files that we've been working on combined into one. Within our HTTP middleware verify CRF token, we need to add the exception for the API route that we set up. And that route again was API update active cell. And you know what? I think we called this API update active cell position. And we did. So let's change it back. Save that. Run gulp again. And we should be good to go. Let's see what happens when we test the route. So homestead SSH to fire up the node server. Let's cd into our project directory. Run socket.js. Looks like it's running. Refresh. There's our grid. There's our grid, but it looks like we're getting an error. Socket.io is not a function. Socket.io is not a function. Socket on is. So let's exit out. Rerun gulp. Get back into homestead. Run node again. And see what happens now. So we're not getting that error. User changed active cell, unexpected semicolon. User changed active cell. Yep. I'm sure you saw that. Save it. Try it again. It's not one of our JavaScript files, so we should just be able to reload. And there we go. Let's check our console. It's outputting the row and column index values and updating in both browsers at the same time. Let's take a look at the command line console output as well. As you can see, each click event is being intercepted by the node server, and it's outputting the click cell channel as well as the formatted event and name we pass to it, as well as the data, the row index and the column index. And this is what gets communicated back to the client here. So the client is listening on the click cell channel. It registers this event coming through, receives the data, calls the update active cell position method here, which is in our action file. The mutation gets dispatched here, updates the state directly with the row and column index values here, and our getters respond accordingly, updating the DOM here. So there's our real-time grid example using Laravel, Vue.js and Vuex, and a few other helpful packages. If you made it this far, thanks for watching. The experience of writing the tutorial and recording the screencast was intentional in order to help me learn these concepts better. And in that, it has served its purpose, and hopefully it has been helpful to you too. Thanks for watching.